Good morning, dear students. Hope you are doing well and also you are listening well all the subjects, and I'm feeling that you are more attentive to all the online classes and getting ready yourself to face the upcoming examinations. I mean, the mid examinations which you are going to face as per the academic curriculum. We are already in second unit, very close to the end of the unit. That means last topic of second unit we are discussing now. See our image classification. Image classification is the part of image analysis, which is the title of, which is the theme of your second unit. In the second unit, the first topic, elements of visual interpretation, we discuss. In the second one, the heading is digital image processing. In that, we finished image pre-processing, followed by image enhancement. We have finished image enhancement, and this is the last topic of second unit, image classification, which is divided into supervised and unsupervised classification. In the previous session, we have seen the supervised classification. Before we are going to discuss about the rest of the part of classification, again, we'll have a brief look of this classification. Why this classification is needed. See here, it is a procedure. It is a procedure to categorize all pixels of image automatically to the respective land cover classes. That's what we discuss as a definition to this image classification. See here, the image is always in remote sensing with respect to the digital numbers, DNs, which is unable to understand to the user. Instead of DNs, if we give the class name, the end user will get the benefit. And he can easily interpret. That's what we are doing in this image classification. What is the definition? It's a procedure to categorize all pixels of image automatically to land cover classes. Of course, it's the process of extracting information classes. Information in the sense what type of class it is, water body, soil body, or else soil, urban area, road network, something else, from a multi-band raster image called as image classification. Now, see here, this is FCC here, false color composite. In the previous class, you understood what is FCC, what is true color composite. Here, based on this FCC, the true color based on the FCC, a map will be prepared which has the legend. What it is. That means the satellite image has to be interpreted in the way that user can easily identify what it is. This is just a trimmed image for your understanding purpose. I kept in this slide. See here, this is what we are discussing here. Image classification. Which image? Spatial image, spatial pattern recognized. After that, it is going to divide into two categories, supervised and unsupervised classification. Now we are here at supervised classification. Supervised classification consists three stages. We have seen training stage where the analyst will get the data of the location through field surveys, maps, aerial photos, and also his own knowledge. Based on that, he will identify the digital number, the pixel area, and he'll try to give the class name by by estimating numerical description of the resolution of all such pixels of all the bands where the image is stored. As you know, each image that has scanned by sensor will be stored in minimum of 4 bands. One is the first two, 1, 2, 3 bands comes under visible spectrum and INR, infrared band. In these four, the image will be stored. Have a look here, minimum of 4 bands. Analyst has the knowledge at this particular corner water body is there. He used to find out what is the resolution for suppose 56. And he used to get the information, the second band, what is the resolution of water body, some 30. Again the third band, some 40. That means based on the values, he will give the range 56 to 30 or some 25 fourth band gives equal to water. Automatically it gives the algorithm. Based on the algorithm, at the output, it gives the class names. Likewise, we have seen for this, the analyst has to have the knowledge, a real-time knowledge of the image. Whatever the source he may get, the knowledge, either maps or field surveys or analyst own knowledge or aerial photographs. He knows. And the classification stage, we have seen two types of classification. One is minimum distance to mean method. Minimum distance, the name itself revealing to us, minimum distance to mean. See here, all these three classes are classified. All these pixels are classified. This is band 1, band 2 digital numbers. Band 1 digital numbers and band 2 digital numbers. Under band 1, see all these are the resolution of the images, and this is for all these pixels, the resolution, based on the resolution, one numerical description has formed as an algorithm, and all they comes under one cluster by name class C, maybe water body. Likewise, band 2 and band 3, A, B, C. One particular pixel, the resolution is not matched, not comes under any one of the numerical description, but it is appearing isolated, appearing individual. In this case, we need to identify to which class it belongs. For that, this method speaking to us to that particular location, one straight line will be laid. From where? By finding out all the values of the mean values from all the digital number values. Wherever the mean value comes, or as the pixels where the mean value holds, from that particular point, one straight line will be drawn. Likewise, to all the nearby classes, whichever the shortest distance from the pixel, unidentified pixel, this pixel goes to that particular class category. Here, it is appearing class A is somewhat close when compared class B. Somehow, the class is far away, but it is in these two, it is appearing like that class A is near for visualizing. So what I am concluding is here, see the distance will be measured And the see here the distance, whichever the shortest distance, whichever the class is near to the particular unidentified pixel, that pixel comes under the nearest category of class. This is what about minimum and maximum classifier. And next one is parallel pipe and box classifiers. Nothing is there here. In the previous case, the distance was measured. Here, the box were framed. Here, the, the location, or else the unidentified pixel comes to whatever the box class, automatically the unidentified pixel will comes under to the particular box class. Now, if I opt to this one, the pixel comes to shortest, the pixel comes to the category of whichever is shortest distance to that particular area. Now is a box, whichever the box it comes under, that particular unidentified pixel goes to the name of, or it goes to that particular class of the box. That means here my doubt is whether it is correctly classified or not. In the first instance, the distance is the matter, here the box is the matter. Here, even the distance is very close to the group, it may not fall down to that group, but the X box will the matter here. That is the reason there must be an accuracy test. At the end, we are going to discuss. After unsupervised classification, we will discuss accuracy test. What is accuracy test? What is the ABCD of accuracy test? We'll discuss this at the end of this session only. This is what we discussed in the previous session. Now is unsupervised classification. Unsupervised, the name itself speaking to us. In the first case, the analyst has to have the knowledge, whatever might be the source, he may get the knowledge. Either from fields, either from aerial photographs, either from his own knowledge, as he may belongs to that particular area, or maybe some field surveys, maps, aerial photographs, and his own knowledge. Yes, the knowledge of the location of what the image is interpreting. The location image is interpreting, is classifying. In this case, sometimes the analyst may not has the knowledge of that particular area of the area which is in the mode of image. Even sometimes it is not possible to get the data, the realistic data for what in an image mode he is classifying. He or she, some analyst is classifying. In such cases, this unsupervised classification will be adopted. See here, this is the computer uses, or as the techniques, the techniques, what are those techniques we'll discuss. The computer techniques will determine which pixel are related to which class. See here, this is also computerized classification, and this is also automated. And here he has the control, the analyst has the control, like number of classes he has to design, and number of maximum iterations. Iterations in the sense, the literal meaning is again and again. What is this iteration we'll discuss. See here, he has the control over number of classes, what he is supposed to, what he is expecting. And this is also automated classification. And basically the difference between supervised and unsupervised is the one, in the previous instance he has the knowledge of the location and he has the knowledge that he may get through 4 of those sources by name: field trips, analyst knowledge, maps, and aerial photographs. In this case, no such sources are available. That's what the basic difference. Here, likewise, in the supervisor classification, here also 2 categories. A lot and dot research is going on, but so far we have only 2 categories. We have, of course, many other methods are under pipeline, but these two methods are available unsupervised classification and practicing widely. What are those? First one is nearest neighbor approach. What is this nearest neighbor approach? I just mentioned only 2 important points here to focus your mind on those 2 points itself. But whatever I am teaching in this mode, you keep remember and have a rewind after this session. Once after you hear the session, whenever you want, go for rewind and you can get the more clarity. Not only this class, every class, you can go for it. Still, if you have any doubts, I said that from the first class onwards, I keep on stressing to you. If you have any doubts, you are most welcome. You can contact me in the domain, whatever you feel convenient. Here, the first point is the unknown sample is classified by calculating the distance to the nearest training classes. Here something is calculating what the distance. By hearing that, you may be remembering. You may remembering that what we discussed bit seconds before and even in the previous session. There is a calculation of distance in which method? Minimum distance to mean method. Here also calculating distance from where to where? From unknown sample to neighboring class. How? If the previous method and this method is same, why 2 names? There is a difference of approach. See here, what is that? Have a look over here. What is this? Nearest neighboring approach. Have a look here. See here, 2 classes are there, class A and class B. Once the algorithm has given by the analyst, the clusters are formed automatically. In the previous case, the analyst has given the numerical description based on the resolution of the pixels of the locations what he got the knowledge through 4 of those sources: field maps, aerial photographs, field surveys, and his own knowledge. While after checking of the resolution of particular area pixels, he formed numerical description. But here, automatically the computer has formed the clusters based on the algorithm. Now, one unidentified pixel is locating here. To which class it belongs to? We are not supposed to leave that as unknown. If you are unknown, the classification is not accurate. Something is left without identifying. On the image, if you are observing an image of one particular area, you need to identify, you need to analyze all the things of the image. Am I right? In your class, 50 members are there. I mean, 50 members. You found 49, and the last one also has to be no. Who is he, or else who is that particular student? What I am speaking is here, there is one unknown value. How can? In the previous instance, we have seen here the nearest, shortest distance, but here, of course, shortest distance, but where to where? See here, you are observing one, K is 3, K is 7. What is K? Number of nearest pixels to be considered. Number of nearest pixels to be considered. My question is, I doubt is, why K is 3? Why not K is 1? Why not K is 2? Let me give you the answer. First of all, when K is 3, what are those near to this unknown? 1, 2, 3. The majority is green, so it comes under class B. If I given 1, this is also, and both, if I given 1, that's okay. Whichever the nearest, it goes to that particular class. If I given 2, K is 2, the nearest 2 will be selected. If one comes under class A and the other one comes under class B, which category it goes? It is, one is near to class A, one is near to B. So one extra element has to be there. If I take an odd number 3, here 2 is green and 1 is red, so it may comes under class B. Did you understand? Are you with me now? If I given 2, any of 2 nearest cells locate, it may locate this one and this one. The result is in 4. Understand? That is the reason one decision factor here in this perspective comes under with odd number. That's why I have taken 3, and you can go for even 5. If even number, if the number is same 2 classes, we are unable to find what it is. Understand? That is the reason 3, 5 and 7. Now you understood. How can you classify the unknown pixel? K is 3. 3 here. Have a look. K is 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 6, 7. See here. Understand? Here, that means K is 7 in the sense, not counting all. From this point, 7 classes has to be calculated. See here, 1, 2, 3, 4, 5, 6, 7. When K is 7, it goes to the class A category, because what is the title? Nearest neighbor approach. What is K? Number of nearest pixels to be considered. See, the number of pixels near to this unknown pixel is red color class. That means class A. If I given K3, it comes under K. It comes under class B. That's why I said in the previous class, sir, if we followed 3 and 7, there is a discrimination is going on. How can I find out exact class it is? Class A, if it is class A water and class B land, maybe some forest. When K is 7, if class A is water, if K is 7, K is 3, and class B, let us assuming that class B is forest, class A is water. When I given K is 3, it falls under class B. That means it may be forest area. If I given K7, it comes under class A, it might be water body. That means how can I come to conclude whether it is in a water body or forest? For that, I said that there is a accuracy test. Accuracy test we'll discuss. What is accuracy? Sometimes it may be observed every time when you are, not sometimes, every time you're observing, when you're writing your examinations, your invigilator used to compare your hall ticket image and you. The image that is in the hall ticket as well as used to compare your face also. For accuracy, we'll discuss what is accuracy test. Have a doubt here. Doubt here in the sense, this is what, whenever you got a question to write an answer, this is what you must write. The unknown cell will be classified based on the nearest pixels, number of nearest pixels, where the k is number of nearest pixels to be considered. The k will be taken as k1, 3, 5, 7, always odd numbers in order to take the majority of pixels, because through which we can find out, we can give the class name. That's what you must write when you are attempting this question, unsupervised classification. The first one is nearest neighbor approach, and the second one is K means approach. See, have a look here. Image classification. See, clustering by various methods such as K means approach. I mentioned here K means approach only, but here we discuss nearest neighborhood approach, and the next one is K means approach. What is K here? In the previous case, K is number of nearest pixels to be considered. Now here, K means approach. For the first one, it's computer-based approach. It creates clusters of the data automatically. Which cluster? These are, what are the cluster here? These are the clusters. These are the clusters. These are the clusters. Nothing but classes. The first cluster is initially it forms the clusters randomly. After forming clusters randomly, all the pixels based on the resolution will get attached to the respective resolution of the clusters. Did you understand? Once again, it is computer-based approach. It creates the clusters from the data in the sense image. Randomly it creates the clusters based on the algorithm. Once it given the classes names, the pixels whichever comes under those classes automatically divide to and goes to the respective clusters. He'll give the algorithms for every cluster as it is an automatic computer base. The clusters, see here, how many classes you want. There is in a control how many classes you want to take. Once you given the classes, it forms the clusters randomly based on the resolution. All the pixels goes to the respective clusters based on the resolution that has given through algorithm. Or as through the command. See here, after pixel attached to the clusters, and it automatically, one more point is it automatically calculate the mean values of every cluster. Once the mean value is not changing, that is the confirmation stage, all the pixels are formed in clusters and as segregated as clusters. All the pixels are in the respective clusters. That means the clusters are formed. To each clusters the pixels are categorized as the classes. Every time when the pixels are clustering, the mean value is changing of the clusters. Once the mean value is constant, it is the confirming stage, all the clusters are formed. What are the clusters? We only given the clusters. Clusters in the sense nothing but classes here. Classes means water body, forest, urban body, then road network, soil, like that. All the clusters are initially formed randomly. Based on the resolution of those clusters, all the pixels are named with respect to cluster name, class name. Once the mean value of every cluster is constant, not changing, it gives the information. It confirms that image has been classified. Now, like this. See, the pixels whichever comes under this range goes to this blue color. Pixel who has the similar resolution will be formed as green color here. Likewise, these clusters will be formed automatically. This is what about k-means approach. From the beginning, I used to say there must be an accuracy test, which is the important step in classification. See here, for suppose in your BTech certificate or else one of your certificate or upper higher education, your name spelling was incorrectly typed. On your certificate, your name spelling is incorrect, is wrong, and immediately you may approach concerned authority, sir, this is not my spelling. Have a look. Okay, he may have a look. He may look over here. How can he understand whether it is correct or not? For that, you must produce one supporting copy, your 10th class. See, my spelling is like this from the beginning, but here that is not visualizing. That means the certificate of your 10th class is a reference data, and it is the copy to which you are comparing. Now we have an idea right now. Accuracy test, before we are going to discuss what is accuracy test, it is the important step in image classification, and to know whether the class is actually belong to that particular class or not. See here is a color, this is a class, some typographical error. Class or not, whether it belongs to particular class or not. Why it may happen? Because of the resolution, mismatch of resolution. Sometimes it may happen. That's what I said that here. How can I confirm that it belongs to this category only? Because if K is 3, it is class B. If K is 7, it is class A. Actually, which class it is? For that, you need to get the reference data. Based on that only, you can get the accuracy of the truth which belongs, which class it is belongs. Understand? See here, it is an agreement between what? What is accuracy test? It is in a referendum between the classified image and reference data. What is accuracy test? It is the mandatory and it is most important after the classification. And to check whether the classes that are identified is actually belongs to that particular class or not, and which may happen because there might be occurrence of flash because of the resolution mismatches, and it is in a referendum of truth between which can comes out by comparing the classified image and reference data. Now, what are the sources of errors? Number one is reference data and classified image timings. Don't write like this. For explanation point of view, I mentioned like this: reference data and classified image timings. The reference data, that means your 10th class copy. In this explanation, don't write like this. For your understanding, I'm speaking here. The reference data means it might be a map, it might be a satellite, it might be an aerial photograph, it might be a Field survey, it might be something which is using, which is having accurate reference. And classified means what you done. Sources of errors. I said mention here, just focus on timings only. The reference data, for suppose I said in the previous class, take an example of wheat. When you have taken an image at the time of beginning where no crop, only seeding was done. After months, there is a crop. See, the reference data we have taken the pre-monsoon and you are classified the image post-monsoon, and in the classified data you are mentioning at particular coordinate seeding, that means empty soil. But in realistic condition, by the month you reach to the end of the monsoon, it's already plants are grown up, but you are mentioning empty soil because the reference data from where you are classifying the image has taken at the time of pre-monsoon. When the time it reached to the end of the monsoon, the plants are already grown up. If you are trying to classify the image by taking the reference data which you have taken at the pre-monsoon season, the classified image may not match to the existed condition, that means end of the monsoon. Am I right? Your image is, see, somehow you are entering, you are going to abroad, which is very, you not abroad, we are going to a new area which is very new to you, and you have only information someone will identify because your photo sent to that particular person. The photo of that particular age has to be sent to the other person, then only he can identify who you are. For suppose in your hall tickets, instead of your latest image, if you have given your kindergarten photo, how can the invigilator can identify whether the image is yours or not? Now you understood. The reference data has taken at the time of rainy initial stage of rainy season, but you are classified the image at the time of closing of rainy season by considering the rainy season, and you are given that image to the end user where you are speaking that it is an empty soil, but in the realistic conditions plants are grown up. So the timing, you must focus here, the timing. Because of the timings there might be occurrence of error. That is the first one. And the second one is minimum number of sampling points. See, in an area, the number of points has to be taken. Number, what is the number? What is the criteria for this number? What is the source of error? Minimum number of sampling points he has taken. I said in the previous class, maximum number has to be taken. What is the number point here? That we'll discuss here itself. Because of the minimum number of sampling points, there might be a occurrence of errors. For suppose in the area there are 5 classes, but you have considered only 4 classes. Those 4 classes only comes on the image. That 5th class you are not considered. The 5th class is not mentioning in the classified image. That means the image is inaccurate. That means the accuracy is very low because the 5th class is not covered by you. But in the actual scenario, actual location, there are 5 classes. Instead of 5 classes selection, you have selected only 4 classes. Those 4 only comes under the image output, but the 5th one is missed, which gives low accuracy. That means maximum number of sampling points has to be taken to cover all the classes. How can you go for this maximum number? These are the 4 methods. Random sampling. If this is the area, here and there you may take up samples. Based on that, you can compare. Next one is stratified sampling. You are just divided the area into 1, 2, 3 clusters. Every cluster you have identified 5 points. This is somewhat better than this. That means everywhere you are taking 5 points, the accuracy you can expect. Systematic sampling. Here, entire area has been divided into equal grids. But and here also you may get the accurate result. Clustering sample. You have taken 4 areas. In every area you have taken the number of samples, clusters, restricted clusters. Now here in the random sampling you have taken, this is one method. Stratified sampling, that means area has been divided into 3 locations. Here in this particular point, 1, 2, 3 different locations. Every location you have taken the fixed number of samples. This is also one of the good method. Systematic sampling, where the area has been divided into equal areas. From every area sample has taken, and here every area has been divided into 4 clusters. From every cluster sampling has taken. See, by following these methods, the accuracy will move on. The accuracy levels will be increased. In order to overcome those errors, these methods we can follow for sampling, so that we can reduce the any of the methods based on the realistic realistic conditions. We can approach the sampling methods. Based on these things you can get the accuracy. You can get whether it is belongs to that particular class or not. Now here I am mentioning accuracy tests. There are different tests to find out the accuracy. I just mentioned one test, that is overall accuracy. How can you find out the accuracy based on this method? Simply, for what is this? What is the objective of this overall accuracy? To determine how many pixels are identified and how many pixels are not yet identified, or else how many pixels are correctly identified and how many pixels are need to be identified. In an area, we are just analyzing how many pixels are correctly identified and how many pixels need to be identified. Here in this method, this is not mentioning how many are misclassified and how many are exactly classified. But here in this method, how many are classified and how many are not classified. Based on this, we can go for overall, we can go for classification. This is the simplest method of overall accuracy test. But the drawback is here, we are not considering the how many are misclassified and how many the accurately classified. But to overcome all these things, if we follow these sampling methods, we can, the accuracy will be improved and will be more. This is what about the accuracy test, for what we are doing, whether it has done or correctly or not. And this is the important step. And this is the referendum between the reference data and the image classified data. Source of errors, where the errors may occur during the classification because of the timings difference and because of the minimum sampling points. To overcome these two, the timings must be matched. The timings must be same, whether the reference data timing and the classified image the image that is classified timing must be same. Then only the error can be overcome, and the maximum number of sampling points has to be taken by following based on the existed conditions. There are 4 methods: random sampling, stratified sampling, systematic sampling, cluster sampling, to overcome the to go for good accuracy, overall accuracy. This is the test to find out how many, where we can find out how many are identified and how many are yet to be identified. Here we are not considering how many are misclassified, how many are correctly identified, but by considering all these sampling methods, the accuracy will be good and more. And there are different methods, but we have discussed one method that's good as part of image classification subject and the curriculum, topic and the curriculum of your image analysis second unit title. Understand? In the image classification, we have discussed what is image classification, and we have discussed what is supervised classification, what are the categories. See, training stage, classified stage, and output stage. What is the classified stage? Here we have discussed two methods: minimum distance to mean method, parallel pipe method. And here the next unsupervised classification, we have seen here two methods: nearest neighbor approach and k-means approach. Classification accuracy assessment, overall accuracy test will be done by comparing the number of pixels that are correctly identified and number of pixels need to be identified. Based on the sampling methods, we can, based on the specified sampling methods, we can reduce the errors and the accuracy will be increased. And next is output stage: graphic products, tabular data, digital data files, and the maps. From here, the information will reach to the user, and this is the data which we can use as an input to GIS. Did you understand this topic? See here, classification, supervised classification. Training stage, what are the limitations? Complete study of the location, number of training sites, time of classification. This time of classification, just now I said that similar timings. Training sites must be maximum, and here complete study of the location has to be done by the analyst for supervised. Classification stage, two classifiers we discussed. Output stage, see here, tables, digital data files, nothing is, you know what is map and you know what is the tables. Okay, and this is about supervised classification. See, minimum distance to mean method we discussed in today's session only in the beginning. And here unsupervised classification, because here analyst may not have the knowledge in the form of the, even he may not get the knowledge in the, even in the form of table, in the form of maps, aerial photographs, field surveys, and his own knowledge. In that particular point, he'll go for unsupervised classification. Computer will adopt the techniques and forms the pixels into different clusters automatically. Two types: nearest neighbor approach we discussed, and k-means approach we discussed. Accuracy test, just comparing how many were identified and how many are need to be identified. How many are identified? Here I said that miscalculation is not mentioned here, but how can we go for misclassification overcome? By simply by comparing these areas with this adoption of number of, by adopting number of sampling locations, we can overcome and we can go for this accuracy test in a meaningful way, and the accuracy will be more with respect to the classification. Now in this unit I said that here when you have a look over there, this is the second unit. The first topic is elements of visual interpretation. After that, digital image processing. In that, the first topic is image pre-processing. Image pre-processing. We have finished image pre-processing, and next is image enhancement. Image enhancement, and see there we discuss magnification, reduction, and contrast, saturation, contrast. After that, filtration and reference stretch. Of course, reference stretch is one of the method. We have seen under image enhancement, image magnification, reduction, contrast enhancement, filtration, spatial filtering, and then transect extraction, and then color composition. After that, the topic is image classification. Under image classification, there are two methods: supervised classification and unsupervised classification. After explaining what is the supervised classification and unsupervised classification, the accuracy test. This is also part of the classification, not separately, it's part of classification. That means with this, we are finishing second unit, and in the next session, we'll discuss with the topic that is in third unit. Thank you. If you have any doubt, you please contact me in the domain whatever you feel convenient.